All right, now let's take a peek into protocols. Now to get into the protocol side of things, some of the things we need to look into is the section of OSI model. And hopefully with previous courses you've taken and previous knowledge, you have an idea of what the OSI model is and the order of the layers and so forth. We're going to cover this here, but make sure that you know the order that it goes in. Other things we're going to be talking about here too are going to be TCP/IP, and we'll take a look at that. We're going to look at ICMP, your Internet Control Message Protocol, UDP, User Datagram Protocol, ARP, your Address Resolution Protocol, DNS, Domain Name Service, SSH, your Secure Shell, and your Simple Network Management Protocol, also known as SNMP, and SMTP, your Simple Mail Transfer Protocol. So let's take a peek at these, and again, make sure you know these, this important information as in what order the OSI model goes in and things like that, because that will assist you in answering questions correctly, just to say, hey, what's between the application layer and the network layer, or something to that effect. All right, anyhow, here we go. Let's take a peek at the application layer, which is the top layer, also known as Layer 7. Now, Layer 7 is the application, as we already mentioned. This is where protocols are going to be allowed the applications to communicate to applications on the remote system. All right, now this is not where the applications work, but the protocols that support the application's networking functionality. Now, some of the protocols at this layer would be your Simple Mail Transfer Protocol, which also runs on port 25, HTTP, which runs on port 80, that's your Hypertext Transfer Protocol. We also have the Line Printer Daemon Protocol, or LPD. A lot of times you're going to see something like that, possibly something like 9100 as the port number, which is also your Jet Direct. All right, the FTP, your File Transfer Protocol, which is going to be port 20 and 21. And you have Telnet, which runs at port 23, and TFTP, which runs at port 69, which is your Trivial File Transfer Protocol. Next up on the list is the presentation layer. And this is going again from the top down. And with the presentation layer, no protocols generally work at this layer, only services, and we're only concerned with the syntax of the data there. Data conversion into standardized formats such as GIF, ASCII, Unicode, JPEG, and TIFF are done at this layer, and also encryption, decryption, compression, and decompression are going to be at this layer. All right, so we have data conversion, and we have encryption, decryption, compression, and decompression happening at the presentation layer. Next up on the list is the session layer. Now, functionality here is the dialogue management between the programs, which gives us access control, recovery, and synchronization. We have setup, maintenance, session teardown of sessions, communication channels, and so forth happening at this layer. Depending on the protocol at this layer, communication can take place either via full duplex, which means two-way conversation at the same time, or half duplex, which only one application can communicate at a time. And some of the protocols that work at this layer, we have SQL, NFS, and RPC, which we'll talk about here later as well. All right, then we have the transport layer. This is the end-to-end packet transfer using connection-oriented or connectionless protocols. Now, the transfer protocols are then concerned with getting the data from one system to the other. It does not work with application-to-application communication, however. Now, use the ports to communicate with higher-level protocols and then to track different communications taking place. We have segmenting or appropriate size of packets for processing by the network layer, and some of the protocols that work here are UDP, TCP, and SPX, which is going to be used for your Novell systems, at least back in the earlier days. But nowadays, we're pretty much only really using TCP and UDP. Now, the next up is the network layer. This is where your routing takes place. So the routing of the packets and addressing takes place here. Routing protocols generally will work at this layer. And when a packet is sent down from the transport layer, the network layer protocol then allows and adds the address to create a network header. Confidentiality, authentication, and integrity can also be provided at this layer. This, however, is done through the use of IPsec, your Internet Protocol Security, and then some of the protocols that work at this layer. Again, these are going to be some of your routing protocols here, which is IP, your RIP, ICMP, IGMP for your Internet Group Management Protocol, IGRP, and BGP. The data link layer. Well, we're working our way down, aren't we? Now, data link layer, the sender breaks data into frames, then transmits sequentially the format frame for proper technologies such as token ring, Ethernet, and ATM, as in your asynchronous transfer mode. Referred to as framing, we have the media access, which is token passing via the CSMA, which hopefully you've heard of this before, your carrier sense multiple access, and then we have collision detection and collision avoidance along with that, depending on what we're using, if it's Ethernet or token ring networks type of scenario. We have polling that goes on here, which also takes place at this layer. Synchronization and error control also happens here, and it also has two sublayers. This is the logic link control layer as an LLC, and the MAC, your media access control layer. Not to be confused with the MAC address, which is your physical address of your network card. This is media access control, again, a sublayer of the data link layer. All right, we also have your WLAN, your wireless LAN, and your token ring as well. So 802.11, 802.5, and such. So as you can see there, how it's kind of broken down. And there you go. Now, also I wanted to mention, this is also the layer where ARP cache poisoning and DNS poisoning and spoofing occurs. Okay, so that might be something pertinent to remember. Then we have the physical layer. Now, the physical layer, the functionality here turns bits into voltage. The encoding of voltage binary representation varies between your LAN, MAN, and WAN, as in your local area, your metropolitan area, and your wide area networks technologies. Right? That provides standards for interfaces to media, types of electrical signals, and formats depending upon the transmission type. We can do photons for fiber, for instance, electrical voltage for Ethernet, and so forth. Right? The radio frequencies for wireless as well. There it is, your 7 layers. All right, so when it comes down to the TCP/IP suite, interestingly enough, you need to obviously know that TCP/IP is a transmission control protocol, internet protocol. Here we're specifically talking about IPv4, as in version 4. We also have IPv6, and IPv6 is going to be running a little bit differently, but here let's concentrate on IPv4 at least for now. All right, we have TCP, which is connection-oriented transport layer protocol, meaning that it has to have a session established before it can transfer data from one computer to the next. All right, we're going to take a look at the information that's within the TCP/IP suite. All right, we'll look at IP, connectionless network layer protocol. It's basically responsible for kind of getting you to the destination. The suite of protocols that govern how it travels over the network, and again here you can see kind of the TCP header, get the source port, destination port, a 32-bit sequence number, which will be important later on when we talk about hijacking, such as session hijacking and TCP/IP hijacking and so forth. It comes all down to knowing what the next sequence number is and things. All right, we also have a 32-bit acknowledgement number. We have a header length. We have some reserve there. We have then this urge, act, push, reset, SYN, and FIN, which we'll talk about in detail here in just a moment, because you will need to know the differences between them and when they're used. All right, we also have a window size. We have a TCP checksum, also known as the CRC, the cyclic redundancy check. And then we also have a 16-bit urgent pointer and any other options, and then of course the data within. All right, so let's take a peek at some of this. Before we dive into that, we're going to look at port and protocol relationships. And again, as I mentioned before, knowing port numbers and their relationship to what service they're running will definitely assist you in getting the right information and getting the answers correctly for simple questions like, what port does FTP run on? Or what port does SNMP run on? And you should be able to identify those for some easy answers just by knowing and memorizing some of the port numbers. Okay, so when we're looking into knowing port numbers and so forth, there's going to be a few you need to remember and memorize, because again, this will just assist you with answering some of those questions correctly. Now, port numbers are going to be mapped to specific protocols generally, and these are well-known ports. They're anywhere from 0 to 1023. Now, we have things like your file transfer protocol, which is used to copy files, move files, and so forth, which, again, we'll get into a little bit greater detail here in a few moments as well. All right, anyway, we use this port 2021. SMTP, your Simple Mail Transfer Protocol, runs on port 25. Now, some dangers there with port 25 is that we can use that mail server as a mail relay. And that basically allows us to send out, if we wanted to, thousands or tens of thousands of emails unsolicited using your mail server. So the dangers there with having port 25 open is that someone can use it as a mail relay and spam the heck out of you. Now the SNMP, your Simple Network Management Protocol, which runs on port 161, it is responsible for allowing us to actually connect into a remote device and manage it and so forth, very similar to Telnet. And a lot of times you're going to see it with printers, as in when printers get set up and so forth. Now the dangers there with SNMP, as we'll mention again, is going to be that you can expose a lot of information unwillingly, mainly because everything in SNMP is transferred over in clear text, unless you're using version 3. So version 1 and 2 is clear text, version 3 is encrypted. So we'll mention that again here shortly. Now HTTP obviously is going to be a clear text, and it's going to be used for web browsing. We have our counterpart, which is HTTPS, which is your Hypertext Transfer Protocol over SSL. It runs on port 443 and is also very important to remember. Now Telnet, again, allows us to connect to a router or whatnot using port 23. It is insecure because it is in clear text, and again, you need to watch out for that. Now, of course, to protect all these services and protocols that are being used, we use something like IPsec to encrypt everything over the network. Okay, anyways, the source port is usually a high dynamic number, while the destination port is usually under 1024. Now, when we say high dynamic number, we're basically talking about like a 49,000 number. So let's see if I can show you guys what I'm talking about here. So if I do use a tool called netstat, for instance, and use something like netstat -an, you'll notice here it's going to show me port numbers, right? And it tells me what's established and what's listening and so forth. So here it tells us on our 127, and then also gives me the port numbers. So you can see here we have the 49,000, right, 26,000 and so forth. We have 52,000 and so forth. So you can see here, this is what they're talking about, those high dynamic ports. It usually will start off in the 49,000 range and then work its way up. Now you notice here I have port 80, port 135, 443, 445, and so forth, 3389, which is actually for remote desktop, 5900, which is actually for VNC, and so forth. So you should be able to identify some of these ports just by looking at them and say, oh yeah, the 445, that's SMB over TCP/IP. And if I see port 135 and 445, or 139 even in 445 and so forth open, that means I can do a null session. Like see here, we have a 139 available and things. So we should be able to identify what ports are running, because the port numbers are going to be very, very important in regards to what's running, and we should be able to identify that. So anyways, so that's some of that, and that's what they're talking about with those high dynamic numbers and so forth. All right. Now TCP and UDP uses ports to communicate with upper layer protocols. So again, the conceptual use of ports is, as you can see here, we have TCP and the UDP side. Depending on the type of protocol you're using, type of service you're using, then it will use the appropriate UDP or TCP ports. Because on the TCP side, we have 65,535 ports, but we also have 65,535 ports on the UDP side as well. And some services will use both UDP and TCP. For instance, DNS will use UDP and TCP port 53, which is for your domain name service, as in this allows us to possibly do zone transfers and things as such, and things like that. So again, knowing those port numbers will definitely assist you in answering certain questions correctly. All right, so let's take a peek at UDP versus TCP real quick. Now TCP is going to be connection oriented, meaning that it has to complete the three-way handshake for it to start transferring data. And the three-way handshake is very simple. It's the SYN, SYNAC, and ACK. And we'll talk about the flags here in just a moment as well. But that's basically your synchronized flag going out to initiate the connection. It sends back a synchronized acknowledgement stating that it got the sync packet. And then it completes the three-way handshake, what we refer to as the three-way handshake, with an acknowledgement. And then once that happens, it can then start sending data back and forth. Now, there's also something else involved. It's called the TCP IP sliding windows concept, and basically it means that whenever it sends data, it has to reply back stating that it got the data so it can then send more and so forth. And that's what we mean by connection oriented. It is also very, very reliable, and it performs a setup handshake. Again, error detection and correction is also there, and this is where they also mention the windowing. Again, I mentioned this as the sliding windows concept. And every server and workstation has this and so forth. So anytime you're connecting to a Windows machine, it's definitely going to go through that process. And again, what it does, with the windowing, it only allows certain amount of information in, and then as it receives it, it then opens it up again for more information to be able to come in. But again, it's guaranteed delivery. Now with UDP, User Datagram Protocol, this is connectionless, all right, meaning that it doesn't have to have the three-way handshake completed to be able to send data. So it doesn't have to have that connection before it can send the data. It just sends the data. With that, it is unfortunately unreliable. So no handshakes being performed, and it uses the best effort protocol. It just sends it out there and says, well, if it gets there, great. If it doesn't, oh well. Because there's no confirming that it received the data as it is with TCP, where it comes back and says, hey, I received packets 2, 3, 4. And then it slides on over and says, okay, now give me packets 11, 12, 13, and things like that. So it kind of goes back and forth. Connectionless is very fast, however, it's not reliable. So a lot of times UDP would be used for streaming, so it's streaming video and so forth. So usually the example I give here, let's say you're looking at a YouTube video, for instance, or something like that. And you're noticing that when the video moves and it blacks out but continues to move, and you maybe miss a couple of seconds or whatnot, that would be something like UDP. Whereas in TCP would be, okay, you get to a section, then it stops, it buffers, and then continues right where it left off. So it doesn't just continue on, right? And that would be more like TCP, where it's waiting, so there's guaranteed delivery, and you're not going to miss anything. UDP, again, just sends it out. It doesn't provide you that guaranteed delivery because it's not expecting, or it's not saying, hey, I received this, send me more.